Hey guys, trying something new right now. So here is a video walkthrough of this study guide. If you're not one of my students, I recommend you not watching this video because it's going to be pretty boring. If you like watching someone talk through several Algebra 1 level problems, then you could watch this, but this is really just meant for my students as a study guide. So with that in mind, I'm going to try and keep this as brief as I can, but also thorough. So this is a good supplement to my shorts. And yeah, we'll just go from here. So this is chapter 7, polynomials. This first set of questions is asking several things. It says to write the polynomial in standard form, which I'll remind us is decreasing order of degree. And my writing, I just realized, is pretty bad. But yeah, we'll get these in standard form. So might as well just do that for the first one right here. For instance, I see 3 terms, and it's degree 3, 2, and 0. So just carefully arranging them so that I have all the signs preserved and decreasing degree. That is this in standard form. All right, same thing over here. This is degree 1. This is degree 2, checking out the exponents. So in standard form, it's going to look like this. Okay, next thing this question is asking for is a classification based on the number of terms. So all you have to know is 2 terms means binomial, 3 terms means trinomial. So I can write that in. It's also asking to identify the degree. So the degree is equal to the largest degree of the terms. So for instance, this one is degree 3 because of this 3 right here. And this one is degree 2 because of that 2. And the leading coefficient is the number that's in front when you are in standard form. And so for leading coefficient, I'm going to write -5 for this question because of the -5 right here. And then for this one, oh, sorry, I didn't write down a 2. Leading coefficient is 2 because of the larger 2 that I just circled. And so there will be questions like this on the test. These are easy points, guys. Please know these definitions and know how to identify the parts of a polynomial. Okay, moving on. We have a couple adding and subtracting questions. And so I didn't include that many on here. A couple ways you could do this, but I mean, let's just, for the sake of time, for the adding questions, you really don't have to change anything. And as long as you're carefully combining like terms, you should be fine. So for instance, 2x squared plus x squared. A lot of people missed this on the quiz and wrote x to the 4th, but this is actually 3x squared. So something I've been stressing is just think of x squared as a thing, right? So if I have 2 of a thing and 1 of a thing, there's 3 things. So the exponent only changes for multiplying, not for adding or subtracting. Here we have -3x plus 5x, which, again, please don't make a mistake on this, is 2x. And then we have 9 minus 4, and so this is 5. And so as long as we don't make any mistakes there, then that's simply adding. And you could keep track of your like terms as well. I was doing this before in class using underlines. But here we can see our different like terms. Like term, by the way, is same exponent, same variable. All right, looking at question 4, this is subtracting, and then this is one that we just want to be extra careful with our signs. So what we really should be doing is distributing to remove the parentheses, which means on this one, all the signs are going to change. But then from here, you can just go through and combine like terms like usual. So again, 3u squared minus u squared is 2u squared. 5u minus 4u is 1u. And -6 plus 9 is plus 3. And so guys, please just know what you're adding and subtracting, know which numbers are changing, and if you need to check this on a calculator, please do that because it'd be really silly to lose points on this part of the question. All right, moving on to multiplying. So we'll try and go as quickly as we can here. This is foiling or distribution. And so the way I usually think of this is with just making sure that everything from this group gets multiplied to everything from this group, or something along those lines. Those steps can change and are fluid, but in general, you take the first term, you multiply it to both of these terms. So x times x is x squared. X times -5 is -5x. And then you repeat the same process here and here with 3 and then also x and -5, of course. So 3 times x is 3x. 3 times -5 is -15. And then just look for anything else that you can combine. So in this case, I do have some like terms in the middle here. Negative 5x plus 3x is negative 2x, and everything else stays the same. And so that's the basic process. You just want to be careful not to make small mistakes. For a binomial going into a trinomial, my preference is to take the binomial into the trinomial. That just makes more sense to me. But again, you can go in this direction. But I'm going to do this. I'm going to take the 2x and then go to x squared. That's 2x cubed. I'm going to take the 2x and go to 3x. That's 6x squared. 2x to negative 1 is minus 2x. Apologize for my left hand blocking the words. And then we do the same thing with the 5. So 5 to x squared is 5x squared. 5 to 3x is 15x. 5 to negative 1 is negative 5. And so here we can just check 3 terms into 2 terms should yield 6 terms, and then we just combine like terms. So I have 1 x cubed term. I have 2x squared terms, so that's 11x squared. I've got 2x terms, so negative 2x plus 15x is 13x. And then I've got one constant, negative 5. Going through this, let's see. Do I want to do all of these? Yeah, it's actually not too bad. So here we've got y plus 3 squared, which if you remember is y plus 3 times y plus 3. That's what it means to square something. And so this is essentially just a foiling question. If I write it out like this, the steps are the same as question 5. So just want to make sure that we're not forgetting the middle terms here. That's going to be y squared plus 3y plus 3y plus 9. And then combining together, you get y squared plus 6y plus 9. And that's a good way to do these problems. You can also do them using the formula that we had, which I'll write down here for your benefit, which was a plus b squared is a squared plus 2ab plus b squared. And that's a formula for the square of a binomial. You don't need that because you could always do it this way, the long way. But it is nice to know. And so, I mean, I think with practice, you guys should be able to do this. Here in this case, we have another square. A is 3x and b is negative 2. And so if we know how this works, you get 9x squared minus 12x plus 4. And that gives you a really quick way to get to your answer by just plugging into this formula. Again, I used a as 3x and b as negative 2. Going down to the bottom here, same thing with question 9. Sorry, I don't know if you guys can hear my dog and cat chasing each other in the background. I can FOIL this together, and you're going to get x squared minus 5x plus 5x minus 25. And these middle terms will cancel, giving us x squared minus 25. Or you could recognize that this is a sum and difference, and so it's going to multiply into a difference of squares. And so I'll write that out for you guys as well, in case you're interested. So that equals a squared minus b squared. And this one, I think, actually is really useful to know. It's just going to show up a lot, and it's just a nice pattern because it's just easily recognizable. It has a nice name as well. Difference of squares are sum and difference. And so if I know how to plug into that, in this case, a is 7a and b is 2, then I know this is going to be 49a squared minus 4. And again, that does just save you a little bit of time. Okay, moving on. Let's see here. Apologize for the awkward formatting of these questions. So here it says a rectangular plot is 6 meters longer than it is wide. Find the area of the plot. And so whenever you're solving a word problem, it's always nice to draw a diagram if you can. And so here I have a rectangular plot. I have a width, and I have a length that is the width plus 6. So I always think what you should try and do, if you can, is just take the information that's given and just write out as many equations and relationships as you can. So a rectangular plot, it has a width and it has a length that is 6 meters longer than the width. So W and W plus 6. And this is perfect because this is asking us to find the area, which is just these two things multiplied together. So the area is length times width. And we just said that the length is W plus 6 and the width is just W. So here we have a simple distribution problem. We get W squared plus 6W, distributing the W into the parentheses. And that's actually our answer. Unless we know W, there's no way to go any further. And so here the area is just some expression in terms of W. All right, let's take a look down here. Here's a polynomial, and we'd like to find the perimeter. Here's a quadrilateral and we'd like to find the perimeter, perimeter is adding. I'll write this in. And area is multiplying. These are good formulas to know, but if I want to find the perimeter of something, I'm really just going to add all of these things together. So here we can just do that by combining like terms. I have 9x plus 8x plus 17x plus 5x. That's a total of, let's take a look here. This is 17. This is also 17, so that's 34. Plus 5 is 39x's perimeter. And then we also have a -2, a -6, and a 1. And so that's going to be -8 plus 1 is -7. And so again, we get an expression that represents the area in terms of x. And we can't go any further unless we know the value of x. So that is the answer to this question. Not too bad. All right, moving on. Factoring. Lots of ways that we can go about factoring. So let's see how many questions we have here. Quite a few. So I don't know if I'm going to do all of these just for the sake of time, but let's see how many of these we can get done. When factoring, first thing you should always check for is a GCF. Is there a number or a variable I can factor out? So for instance, on question 13, I can take out a lot of things, right? I mean, I notice that they're both even. I notice that they're both multiples of 4, multiples of 8. They're actually multiples of 16, and so that means I can take out a 16. GCF goes on the outside, and whatever's left inside is, whatever's left, and then we see where we go from there. This is 2x squared plus 1. And then we just want to check this for factoring. And so I am always saying that if you have a quadratic factor, there is a chance that it can be factorable. And so it takes practice to recognize when something is or is not factorable. If you're looking at something like this, here's what you want to do. Take the first and last numbers, multiply them together. Take the middle number, which in this case is going to be a 0. There is no x term. And then you just need to ask yourself, are there any numbers that multiply up to 2 and add up to 0? Since there are not, if you think about it, those numbers don't exist, then that means this polynomial is not factorable, and this is our final answer. This is factored completely because there are no numbers that can fill in this diagram. All right, let's take a look and see if we can keep finding stuff like that. So for instance, on question 14, first thing I want to do is check for a GCF. I notice a 4 and an 8, so surely we can take out a 4. I also notice that these both have x's in them. In fact, they both have at least x squared in them, so we can take that out as well. It's always a little trickier when you're factoring out a variable. From here, we just want to carefully do this division, but 4 divided by 4 is, of course, nothing, or it's a 1. Right? X cubed divided by x squared is x. Then on this side, we have 8 by 4 is 2. The x squareds cancel. And from here, we have a linear factor. And we've got this guy off on the side. You can't factor those either. So if you ever have an x by itself on the front, it just doesn't factor anymore. It's already factored. And so this problem is done. Continuing on, we can go to these problems here. These ones actually don't look too bad. They're all pretty quick. And so one thing I noticed right off the bat for all 4 of these, the coefficient in the front, the leading coefficient is 1. These are also quadratic trinomials. And so this is the simplest form of factoring. There is no GCF to take out. And so all I need to do is just ask myself, what numbers multiply up to 5 and add up to 6? And whatever those numbers are going to be my factors. And so for instance, I do see that it's going to be 5 and 1. And so my factors are x plus 5 and x plus 1. You can always double check that by distributing back into each other these factors to see if we get the original expression back. That's what we did on the last problems, right? The multiplying. Please check your work if you're unsure of your factors. But we want to be really comfortable factoring stuff like this. If you ever encounter a number and you're just not sure, like for instance, -33 is just not a number that I think of that often, you can always list out all of the factors. And so for instance, on this one, for -33, right? Numbers that multiply up to 33 are like 1 and 33. 2 doesn't work because this is an odd number. 3 works, so 3 and 11. 4 doesn't work because it's an odd number. 5 doesn't work, doesn't end in a 5 or a 0. 6 doesn't work. 7 doesn't work. In fact, none of the numbers work. It's really just these 2. And so you can just, I think it's helpful to just write them all out if you're ever unsure. Other thing to think about is I'm looking for a negative product. That means one of these is positive and one of these is negative. And I'm also looking for it to add up to a negative number. And so that means the larger number has to be negative. And so here we have the only two possible things that could even get close to these numbers. And when you write it out this way, it's obviously 3 minus 11. Like 1 minus 33 just is not going to work. So 3 minus 11 are the numbers, and that means our factors are x plus 3 and x minus 11. Uh-oh, did Mr. Shea make a mistake? Yes, I did. So we should match the variables here. It should be u plus 3 and u minus 11. Sorry, guys. I make that mistake a lot. You're going to see a lot of different variables in science classes in the future. So it's good to pay attention to that. Yeah, generally in a math class, though, it's mostly x's. All right, over here, I need numbers that multiply up to negative 21 and add up to 4. So same thing. If we just think about all the possibilities, it's just 1 and 21 and 3 and 7, and then nothing else. If you check all the numbers, right, 4, 5, and 6, those don't work. And once you're back to 7, that's all the numbers. And so we have a negative product and a positive sum. And so that means that the smaller number is going to be negative. And so just by looking at this, it's got to be negative 3 and 7. A minus 3, A plus 7. Here I have a positive number here, but it's adding up to two negatives. And so I know this is going to be two negative numbers, and it looks like negative 9 and negative 3. B minus 9, B minus 3. Perfect. First page done. All right, moving into the rest of these. It's a really similar process. I don't know if I'm going to talk through all of them, but you guys can kind of see in real time how long it would take me to factor these. 36 and 15. Numbers that multiply up to 36. It looks like 12 and 3. But, again, if you want to write it all out, you can. But this is 12 and this is 3. So we have x plus 12, x plus 3. Once you get fast enough, you can kind of do this process in your head. So this work is not necessary to show. But, for instance, if I know what I'm asking myself, numbers that multiply up to negative 42 and add up to 1, that looks like 7 and negative 6, right? Numbers that multiply up to 72 and add up to 17, that looks like 8 and 9. And so, like I said, with practice, this really just does get a lot faster. I promise you that it does. There are only so many numbers that we could give you, right? Like the numbers inside of these parentheses are not going to be huge numbers. Like I doubt if we'll give you guys anything larger than 12. So how many ways can you combine two numbers between 1 and 12? It's actually not as many as you would think. So you'll get a sense of seeing these after some time. Now this one we want to be careful of. So here we have the number in front being greater than 1. And this is where we've got a couple ways that we could do this. So let me show you 3 ways, perhaps. The first way is guess and check. And so by guess and check, I mean, based on these numbers and the signs within the polynomial, there are some possibilities for things that we can multiply together that would possibly yield these coefficients. For instance, 2 means that I need a 1 and a 2 in the front of my factors. And for 30, here we've got a couple options, actually. Sorry, I forgot 1 and 30, 3 and 10, 5 and 6, and I believe that's it. Oh, sorry, 2 and 15. So we've got 4 choices. They are going to be negative and adding up to a negative. So same rules apply as before. The bigger one here is going to be negative, but we just want to, generally the bigger one is negative, but we just want to go through the possibilities of what could possibly, how can we combine these things together to make this? And that's kind of guess and check. And so to really make guess and check work, I mean, I think we've got to be pretty good at mental foiling. Otherwise, there's just too many things to write out. But for instance, just give me a second here and see if I can see this. It's negative 7. So it looks like x minus 6 and then 2x plus 5. And yeah, those are the answers, right? And so here, by narrowing down the choices based on the factors, you have less things to think about. Another thing you can do is this modified x that I had from before. And so here, in this case, we want the first and last numbers multiplied together, negative 12, and then the middle numbers. And then I want numbers that multiply up to the top number and add up to the bottom number. And so in this case, this is going to be, it looks like 6 and -2. And so what I like about this is it gives us a nice starting point. Like if you're not sure about guess and check, we can do this process as long as we remember how to modify that top number. And that gives us a way that we could begin factoring. Um, However, the way that you proceed from here is not the most intuitive. So what you're going to do is take these numbers and split the middle term, 6y and -2y, and then you're going to factor out a GCF. This is grouping, by the way. So in this case, the biggest thing that I can group factor out of here is 2y. Biggest thing I can factor out of here is actually going to be a -1. That one's pretty subtle. And so if I factor out that GCF, what's left in this first group is going to be 2y plus 3. And then if I factor out a -1, what's left in the second group is also 2y plus 3. And if you've done this step properly, these two things should be the same. And if they are, we can just write out our answer from here. And so we're going to factor out the 2y plus 3 again as a GCF. And then what's left is the 2y minus 1 that we have in each term. And so I like this because it's a concrete set of steps that you can use to get to the answer, but it is a lot of steps and it feels a little clunky for a lot of us. So here's an alternate option. For instance, over here, I could begin the process the same way, first and last numbers. I might skip some of these for time. So 4 times 1 is 1. On the bottom, we've got a 4 again. Numbers that multiply up to 4 and add up to 4 are 2 and 2. And then what we can do is take this first number, put it on top. Oh, shoot, you guys can't even see what I'm writing. Put it on top of the numbers that we found. And then here we have fractions that we can reduce. And so if you've done this properly, this replicates the entire process of grouping. And these numbers become the coefficients of our factors, as in 2/1 is 2x plus 1, and 2/1 is 2x plus 1. And so I like that. It's actually a very fast way to factor, and I find it to be pretty reliable. I don't have a lot of space on this, so let's go to the backside. And with practice, you can get the answers to a lot of trinomials of different types. Let's see if I can find one here. So yeah, like for instance, if I wanted to do this one, the 10z squared minus 13z. So again, I've got numbers that multiply up to -30, added to -13. Here, I can already see that that's going to be -10 and -3. And then putting the 10 back in the front, this becomes 1 over -1. My factors are x minus 1 and 10x minus 3. And so even for seasoned guess and checkers, I do like this method. This method gives us several nice things, and that is, one, a direct set of steps to get to the answer, no guessing required, and then also a very basic way that we could just check if something is factorable, which is missing from the guess and check method. Like the only way to be sure in guess and check whether or not something is factorable is to just try every combination, and then you might find that none of them work. That means it's not factorable. This is nice because if these numbers don't exist, then it's not factorable anymore. So you just try something else. Okay, let's go to the back page. Got a couple other things here. For the sake of time, let's see what we can do. So the setup on this, guys, this is here, you can imagine there is a 0 term in the middle for x. And so if you want to use the x method with the 1 in the front, I need numbers that multiply up to -121 and add up to 0, which are 11 and -11. So that's going to be y plus 11 and then y minus 11. The other thing that you can do, of course, is to just recognize that this is a pattern. This is a pattern, kind of. I mean, it's yes, it is a pattern. This is a pattern, right? This is a pattern. These are all the same pattern in that they are a difference of squares. And so if I know how to factor these, this is the sum and difference pattern from before, then this gives us a fast way to write out our factors without having to think too much. So I do recommend that. This is going to save us time. So here, if we take out a GCF, right, we get a difference of squares again, which means that I can continue factoring this. And that all just takes practice, right? Factoring is like solving a puzzle. GCF is n. And so here, you just want as many tools as you can think of to get to solutions. And difference of squares is just one of the most useful ones. All right, last thing I want to go over just for time's sake. So by the way, I'll just give us started on some of these. This is GCF, where GCF is 5x. So this gives us x squared plus 2x minus 60. Nice. This one is now factorable regularly. Oh gosh, I might as well just finish this. 6 and 5. 6 and, is this 2x? So, oh, actually, okay. I'm gonna write this out. 1 and 60, 2 and 15, 3 and 20, 4 and 4, oh, 2 and 30, 4 and 15, 5 and 12, 6 and 10, 7, 8, 9. Is this not factorable? Oh, it's not. Okay, yeah, there's no way to combine these together and get 2 unless I made a mistake. Oh, it's not 60. 120 divided by 5. This is 24. All right, you see, there you go. This is how you can check your work, guys. So I need numbers that multiply up to 24 and add up to 2, and that one actually is a lot nicer now. So this is x plus 6, x minus 4. Whew. All right, there you go. There's some live mistakes being made here. All right, we'll do this last question, guys. So for grouping, just as a reminder, I'm asking you to do grouping if there are 3 terms, because all the other rules that we have are for, if there are 4 terms, all the other rules are for 3 terms. And so this is a cubic quadrilateral, I guess, but a quadrinomial, I don't know. But from here, I'm going to look for a GCF in the first 2 terms. I'm going to look for a GCF in the second 2 terms. I'm going to factor that out very carefully. I'm going to double check that these are indeed the same thing, because if they're not, then this next step doesn't make sense. But if they are, then you factor out that common factor, and then what's left is the GCFs that you found on the first step. Double check for factoring to make sure that this problem is done. And since it is, this can't be factored any further. All right, actually, we just got 2 problems left. Might as well just finish this one up. So on this one, I do see a GCF, so we're going to take out a 2. Nice. I see a trinomial with a leading coefficient of 1, so I just need numbers that multiply up to negative 30 and add up to 1. 6 and negative 5. And then on this question here, I see 4 terms, so for sure this is going to be grouping. And so we can just go through this. Looks like a y squared in the front and a 5 in the back. So I have y squared times y minus 4 plus 5 times y minus 4. And same thing means that we have y minus 4 times y squared plus 5. This is not factorable. No numbers multiply up to 5 and add up to 0. And so this problem is done. And there you have our first walkthrough. Let me know what you guys think. And yeah, hopefully this is helpful for some of you guys.